And we're live.
Sorry, hello.
Okay, hello everyone. Thank you very much for coming today to be with us. I'm going to talk about zero trust, as Andy said, and my talk is called I Want to Know What Trust Is. So we're going to define a pretty mysterious term, something that a lot of people think of as a buzzword. Lots of people mistakenly think that zero trust means don't trust anyone. What we're going to see is this is not true at all. We have to trust everyone to some extent, or not at all. So this is I Want to Know What Trust Is, from the network to the supply chain. My name is James. This is me after making a pilgrimage of a famous fictitious character from the Mitchell and Webb show Peep Show, running from Croydon to Windsor Castle a couple of weeks ago. My legs have just about recovered. I am a principal consultant at ControlPlane, and I also do some music in my spare time. So at ControlPlane, we are a cloud-native security company. We do training, we do DevOps, we do security architecture, threat modeling, and pen testing. You can get a free copy of Andy's book on hacking Kubernetes if you scan that QR code. But enough of the sales pitch, on to zero trust. So what is trust then? So NIST give us this definition. So NIST say that trust is a belief that an entity meets certain expectations and therefore can be relied upon to some extent. So we've got a few examples of this. So in the supply chain, we can think about software attestations. So software attestation is an authenticated statement about a software artifact or a group of software artifacts. And an attestation might say maybe how exactly an artifact was built. It could say something about the vulnerability status of a certain artifact. How strongly do we believe the statement, though? That's where we have to define what trust is and establish a framework for trusting different parties to different extents. On the network, we have multiple parties communicating over some protocol, and party A says, I am whoever I say I am. Radio won't even play my jam. So how do we establish trust then? We're going to use cryptographic primitives, asymmetric cryptography, public-private keys. This is how we prove to one another that we are who we say we are. However, we need a framework in order to attribute some level of order to this. So one way in which people can trust each other is by doing something that looks like the left-hand side of this diagram, so a web of trust. In a web of trust, we have things called key signing ceremonies where people come together and they digitally sign certificates which bind someone's public key to a private key which they own. And you can do things like make decisions based on how many people have signed someone's certificate, and you can attribute different levels of trust to people. But you can see this is very messy. It's a web. You've got trust relationships everywhere. You have some people who trust people more than others. You have people who transitively trust others. This is obviously very, very hard to keep track of. You can see these things in PGP Web of Trust, for example. This doesn't really work that well in an enterprise setting where order is the law. We often end up with a PKI in this sort of setting where we have a hierarchy of certificates, a root at the top, some intermediates signing leave certificates, and the certificate, as always, binds an identity to their public key, which can prove is owned by them. You can see on the left, however, we can make much more granular trust decisions because our policy is not just, well, I trust this or not, I sit under this root or I don't. So there are some subtleties here, but for the most of this talk, we're going to be thinking about PKI, essentially. Okay, let's talk about explicit versus implicit trust then. So again, there was a Spinal Tap joke about lead base at the start of this talk. This is a scene from Spinal Tap of someone passing through an airport. And I think an airport is a really, really good example of explicit trust. So someone goes past the border, they show a passport, and they have to match the photo on their passport to get through. And they have to be allowed into the country. So there is an identity, there is a policy decision, and there's an enactment of that policy decision. The person can cross the border. Once they're through, once they get through security, usually you can do whatever you want, right? So you are implicitly trusted because of where you are. I think this is a really nice example for IT security because in a network, the old style of ascribing trust would be, we have a trusted network over here. And I know this workload is trusted because it's come from this subnet. Now, obviously in cloud native, attributing identities via IPs is a very, very bad thing indeed, because they change all the time. We've got ephemeral workloads. So this doesn't work anymore. We need to base decisions on cryptographically strong, verifiable identities. So what zero trust means then, we can define it very precisely. It doesn't mean don't trust, it means don't implicitly trust. Instead, ascribe explicit trust relationships, understand these relationships, and make trusted decisions based on a policy which you've written. You can summarize it in this triangle. So this is a diagram that Fred Kautz uses a lot. He puts identity at the core. So in order to make a decision, we need to know what we're making a decision about. So we need to have a cryptographic identity document. This could be for a person, it could be for a workload. Lots of this talk, we're going to be talking about workloads. So these identity documents are often X509 certificates or JSON Web Tokens, and both of these have attractive properties. And for example, you might want to use a JOT if you need to traverse a TLS terminating load balancer, but you want to preserve that identity to make a decision about it later on. You have an identity. The policy then is the written statement of what you're going to do, what you're going to allow this identity to do. And in the title of this talk, we talked about networks and supply chains. These are a couple of examples where you might want to write some policies. So in a network sense, can machine A talk to machine B? In a supply chain sense, do I want to run the following binary? So we always need a policy. And we need a control point as well. So control is the enaction of the policy based on the cryptographic identity. So that ties everything together. So zero trust architectures are defined a bit more precisely if we start looking at some rather exciting NIST documents. So this one at the top, NIST SP 800-207, is kind of the canonical document on zero trust. It defines an architecture that looks very much like this on the right-hand side. We have human users, we have machine users, and these are all accessing resources over a network. We have a policy decision point. This is where our policies are loaded in, and a decision is made based on the properties of the network communication. So should machine A be able to hit the slash, etc. endpoint on this endpoint over here? The policy is defined in this PDP. And of course, there has to be an enactment of the policy as well. So we call this a policy enforcement point. And you might be saying, isn't this just kind of like a service mesh? This looks very service meshy. We have workloads, we have potential things that look like proxies in front of other workloads, stopping or allowing traffic to get to the destination. And you'd be quite right. So we can look at a service mesh and understand what's going on in a little bit more detail. Now, this is a shameless plug for a NIST document here, because this is one I wrote alongside Zach from Tetrate and Mooley from NIST. And this is all about different models of service mesh. Now, this one here is the one in which people are most familiar with. It's a sidecar model. So what we can see is we've got an application container over here. We've got two nodes, and we've got two pods on this node, one pod on that node over there. And we have application 1 talking to application 3, application 1 talking to application 2, and all the traffic goes through the sidecar proxies. And these sidecars are doing both the layer 4 and the layer 7 traffic enforcement. So in this case, MTLS is negotiated by the sidecars, and we can think about some risks, and we can compare service mesh models. So in this model, in order to compromise key material, I basically have to compromise one of these pods, right? And if you think about what's more likely to be compromised, is it the Envoy proxy that's running, or is it the application? Now, this is going to depend very much on the scenario where you're in, but in many instances, it's probably going to be the application. So maybe if you compromise an application container in this case, you can maybe steal the identity because you're co-located within the same pod. One thing to note here is there's no separation between layer 4 and layer 7 traffic processing. Layer 7 stuff is more complicated because of the nature of the protocols, and therefore, historically, this has been where most of the CVEs have been. So this is one thing to bear in mind. And then also, we can note that basically, compromise of the app is equivalent, like we said before, to compromise of the identity. So let's look at a slightly different model then. What about if we have a layer 4 proxy per node? So again, we have a 2-node setup here. We have application 1, application 2 on this node. We have a layer 4 proxy here on node 1, layer 4 proxy on node 2. But to get to application 3, we've got to do the layer 7 processing here. And this layer 7 processing is known as a kind of remote proxy. So this thing here, layer 4 per node, you might have heard of Istio Ambient. So in Istio Ambient, we have Z tunnel per node, and waypoint proxies doing the level 7 stuff, layer 7 stuff per service account. So this is better than having like shared layer 4, layer 7 in some senses, because again, that layer 7 stuff is tied down per service account. So in this case, however, the layer 4 proxy has access to all the key material. So if you can pop that proxy, you have access to all the identities. So that's one kind of subtlety in risk profile when you compare with the first topology. Also, it's noted that in this topology, the layer 4 less complex stuff is decoupled from the layer 7 stuff. Therefore, we don't have the argument of, well, layer 7 stuff is always present, so there may be those kind of like CVEs because of this complexity. The layer 7 stuff is there only if you need it. So again, maybe gives you some flexibility to meet certain business requirements. This is another model here. So shared layer 4, layer 7 per node. So an example here is, for example, Cilium mesh. So you have eBPF doing the layer 4 stuff on a node, and then every node will have its own Envoy proxy. For example, I'm not saying this is the only implementation. We've tried to be quite generic in the way that the paper is written, so that we're not slandering implementations or anything. That there are pluses and minuses to all of these architectures in terms of performance, security. So every decision you make is a balanced decision. But yes, this could be Cilium working alongside Envoy proxy to give you this layer 4 and layer 7 per node. And in this case, a couple of the consequences in terms of risk. Now a single proxy is no longer providing an inherently multi-tenant setup. Hence, some security concerns could arise when combining complex processing rules for the layer 7 traffic. In this configuration, layer 7 stuff is performed within one process. There's no memory protection or isolation benefits that could be contained by containerization of the layer 7 functionality, such as was the case in the per service account waypoint proxy example from before. Okay, so moving on to our last one, we could do everything in a library. So we could have a proxyless gRPC client within a container configured via an XDS control plane. Now here, compromising the application is compromising the identity. Again, it's very similar to the sidecar case. One is equivalent to the other. But here, of course, we're kind of coupling infrastructure concerns within the application code, because that's the library is basically doing all of that networking stuff, which is decoupled in a sidecar or a remote proxy in the other cases. So again, just some concerns and things to think about when considering our risk model here. Okay, so we've talked about service meshes a lot, and this talk is not about service meshes, it's about zero trust. So what comes first, the zero trust or the service mesh? Well, zero trust, obviously, because service mesh is an implementation of a zero trust architecture. It's not the only one, it is an implementation. However, what about if we want to go outside a mesh? What if we want to go outside a cluster? What if we have disparate cloud workloads in different cloud providers? What if we have on-prem workloads? What if we've got IoT devices, etc.? How do we deal with identity, the identity part of the couch triangle in these cases? And what we can start to see is that cloud providers are giving us solutions here. So I'm sure you've seen in GCP, you've got workload identity, you've got IAM roles for service accounts in AWS. So cloud providers are providing solutions to this. And lots of people are standardizing on a specification called SPIFFE. So SPIFFE on the next slide will show what it is. This is the Secure Production Identity Framework for everyone. And this is a specification for how to deal with machine identities. Everything is represented by a turtle. You can read an excellent book on SPIFFE called Solving the Bottom Turtle. In this case, turtles are secrets. So the question is, how do we provide identities to workloads without having to do lots of complex bootstrapping. And the Spiffy turtle has 5 parts. The Spiffy ID, this is the representation of our workload. So we have a domain, and a domain, they're called trust domains. So everything comes back to the word trust. The trust domain can be decided based on a number of factors. It could be a security trust domain. You could co-locate things within a domain depending on the sensitivity of assets processed. But it could just be for business reasons as well. It could be different parts of an organization. So you have a trust domain, and then a kind of unlimited part afterwards where you can have a series of slashes, and you can structure your Spiffy IDs in such a way that it helps you to make policy decisions. So we've got the ID. We, of course, need something cryptographically verifiable to encode this ID, and this is the Spiffy verifiable identity document, or SVID. These SVIDs at this point in time can be X509s or JOTs, not surprisingly. And we can do lots of things. We can federate, for example, so just jumping to the bottom, we can have two Spiffy trust domains, and we can exchange trust bundles and federate between organizations or between parts of an organization. And all of this is done via a couple of APIs. So there is a workload API. This is essentially how workloads will get their identity documents. So they talk to a local unauthenticated API, and the magic thing is that they will get their identity documents almost without knowing what they are. So they don't have to have a pre-populated secret necessarily. That will always be a bottom turtle. I'm not saying this solves the bottom turtle problem entirely, but it makes things a bit easier to manage. And then we have trust bundles. I mentioned this in the federation context. This is basically exchanging public key information in order to establish federation relationships. So Spire then. Spire is a open source implementation of the Spiffy framework. So Spire is basically a vending machine for workload identities. It has a server agent architecture. We have a Spire server. The registration API allows us to kind of register our workloads. So we'll have a bunch of selectors effectively, and those selectors define what our workloads will be. And there are many plugins that you can use, which will help you to define essentially what your SVIDs, what your Spiffy IDs will look like for your workloads. So in Kubernetes, for example, you'll have an agent which will basically talk to the kubelet, and you could have your SVIDs being generated by some controller. You could use something like the Spire controller manager to dish out SVIDs based on labels and other properties that the agent can learn. So we have a Spire server at the top. We have lots and lots of agents on different nodes, and the workloads are talking to the agents on this workload API. But what this does, because of this out-of-band mechanism is used for a workload getting its SVID, what this means is that rotation is seamless. These workloads can get new SVIDs when the rotation period is up. It means that they don't need to have some pre-populated secret. Now, of course, there are some complexities here, which I'll come back to on a later slide. But for now, this is what Spire is. What this can do, it can help us in many ways. It can help us to create a singular identity vending source. It can help us to do cross-cloud identity. We can even have a Spire server which serves cloud workloads and IoT devices. So it really helps us unify the identity plane. We still have to talk about policy and control. I think those are a bit beyond the scope of today's talk. So today we're talking about how to get the identity there. There's lots and lots of ways in which you can create the policy decisions. I'll link you to some extra resources that you can look at here, which will show you how. So at ControlPlane, we have a repo here where you can see a Spire integration with Istio. So Istio does use Spiffy. If you have a look at an Istio certificate for the MTLS, you'll see that the names are Spiffy format. However, Istio doesn't fully implement Spiffy because it doesn't do federation and stuff like that. It's a partial implementation. You can actually replace the default CA in Istio with Spire, and that's what we've done here in this demo. So feel free to play around and have a look at that. You can look at Cilium. Cilium have an integration with Spire as well, so you can do things at the CNI layer, and you can do MTLS with Cilium with Spire-generated SVIDs. And then also, just another shameless plug, we at ControlPlane have written a couple of courses for the Linux Foundation. The top one is free, so if you go to the top one, Introduction to Zero Trust, LFS 183, completely free. There's about 6 labs, a few videos. That will teach you the basics of building up a zero trust architecture from scratch using Spire and policy engines like OPA and enforcement points like Envoy proxies. You'll in fact almost build a service mesh from scratch in this course. The second course is a much longer course. It's a 3-day advanced course on Spiffy and Spire and how to run Spire deployments. This is a paid course. If you want to talk to me about how to apply to be on this course, here all day. Otherwise, the link should be enough if you ever feel like doing this in the future. Okay, we're nearing the end, and I realize I'm slightly over. Apologies. We have supply chain security in the title of this talk. However, we've not talked about it much. That's because the concerns are basically the same. We still have the identity, policy, and control triangle. If you have a signed artifact, you still need to know what level of trust do I attribute to the signer of this artifact. Do I indeed trust that this person who says they produced this thing did produce it? The same approach applies here. And then I mentioned that subtlety as well with having to not have a bootstrap secret in order to get your identity documents. Don't think that that gets you out of trouble though, because it depends the integration that you set up to automate the distribution of these identity documents. For example, if you use labels to define what a workload will look like from a Spire service perspective in Kubernetes, who can label, who can change labels, who can add labels? So the important message and the note to end on is that threat model everything. Try and understand where your bottom turtles are, because there always are bottom turtles. There will always be some sort of bootstrap secret. Understand where it is, understand what risk you are opening yourself up to, and make sure that there are appropriate protections in place. That's it. Thank you very much. Any more questions? I'll be around.
Wonderful. Thank you very much indeed. Does anybody have any particularly spicy questions that they would like to try and impale a good man with?
I got questions from later.
Okay.
Later we can talk
that's very kind.
Over a bit.
About that.
Okay.
Okay. Good job. Right. Thank you very much. We now have a couple of minutes. If you'd like to rehydrate yourselves or the opposites, then we will start again in about 5 minutes with Mr. Ian Smart.
We will eventually, yes.
Where I have to stream data. Slack.
I'm doing a great job with this. What's going on?
Yeah. Okay.
Would you like to do
I sent it.
I can just grab that. That's over there. You're in our full screen thing, but that's fine. We can get rid of that. We can move. Where's my mouse now?
You're trying to hurt one. You done that?
I know. I'm really, really sorry. I can explain. But also, you'll never have to deal with me again, so it's fine. I'm already dead. Can we just go to the action and you'll have to see it?
I just want to.
Because
I just have to see if it's still rolling.
Oh, shit. Yeah, fair.
Andy said he did.
Of course he did. That one?
No, the. Why do you even have Safari? I don't know. It was on my laptop.
Which one is
I
it?
usually have. Oh, oh, good.
We good?
I don't think anyone's even going for it, to be fair. You can.
Oh yeah. It looked really good, and then I added in the extra line on the way here, which to say where I did the presentation, and it just bumped everything up. I'm really fucking angry at it. To be fair, I am using the official presentation things. The official background is not. If anyone was ever going to use it, really, I'd have dropped the actual CSS and wouldn't have had someone that would use it. But I know. Oh, I'm genuinely upset. Don't answer that honestly. Andy off like a rocket, Martin. It's off like a rocket, not off his rocker. I did once describe you as one of the most ADHD people I've ever met. Yeah, it is. Oh, that's it, and this is a text. I forgot to read all my slides.
It is with the greatest of pleasure that I am ready to introduce our next speaker, Mr. Ian Smart, as you can see. Order. Right, it is with the greatest of pleasure and the minimalist of latency to introduce Mr. Ian Smart, who is not talking about the other thing he was speaking about the other day, but something similar, which is how shadow and static pods on Kubernetes can cause unlimited trouble. And I introduce you to the troublemaker. Once again, a thunderous round of applause. Ian Smart.
Hello, everyone. Thank you. This is Static Pods Are Weird. Fun fact, I'm also using this presentation to trial a new way of building presentations, which is why this is called Static Pods Are Weird, and this is a test. This is not meant to be a test. I think my pipeline failed silently on the way here. Fun fact, happily we'll talk in great detail about how I over-engineered building these at some point. I am Ian. I like to introduce myself as an agent of chaos at ControlPlane. I'm a penetration tester by trade. I graduated with a degree in ethical hacking and countermeasures, started breaking all sorts of things, realized web apps were boring and infrastructure was cool, then found out about this weird thing where it's actually infrastructure, but really it's APIs. And I'm a bit conflicted because technically I'm an API tester, kind of, and I really don't like that. I have been doing DevSecOps stuff for a good few years now. I deliver training, I ramble at random events, and as we're about to find out, I go down really deep rabbit holes for no real reason because something seems odd. So unlike James's nice overview of quite a wide range of tech, I'm about to deep dive in something really specific. I also have no idea how long this presentation will take. We will find out together. So, static pods. Anyone familiar with static pods in Kubernetes? Couple of people, especially the control plane ones. I see 4 hands and they're all control plane because I've been speaking about this for the last 2 weeks. We're going to talk about why these are interesting and why I care about them as an attacker. And then we're going to talk about some of the weirdnesses. Static pods exist to solve a bootstrap problem. Kubernetes often runs, especially in things like kubeadm, the control plane itself as pods in a cluster. So if you do kubectl get pods, you will see that the API server is running as a pod. The problem is, you need the API server running to be able to get any pods to run. So how do you solve this problem of bootstrapping up your first couple of pods to make everything else work? The answer is that the Mermaid.js takes a while to load. Even better, it loads there, but it doesn't load on the speaker notes. So I will have to look at this. This is wonderful. Effectively, what we've got is the kubelet is constantly polling the control plane and saying, hello, do you have anything for me to do? Fun fact, this is the reason that you cannot talk to the API, to the kubelet, and start a new pod. You can talk to running pods to the kubelet, but there is no API endpoint to create a new pod directly on the kubelet because it's constantly reaching out for something to do. So if you've got your control plane running, the kubelet says, hello, I'm node 1, what have you got for me? The control plane says, run these things, please. And the kubelet goes, okay, those are running now after various levels of CRI and some kind of container runtime and all sorts of abstraction. But the control plane does determine what's running. The problem here is, what happens if we've only got a void and the kubelet is constantly reaching out and saying, do you have anything for me to do, and gets nothing back? You can actually demonstrate this. You can run the kubelet standalone. You can say, talk to this IP address, and it'll just spin there forever. You'll probably get something in the logs that say, nothing for you to do. You can also create an empty node and add all sorts of taints and kind of make sure nothing gets scheduled to the node. You'll see the same behavior. So we need to make the control plane pods run. There are other things this can be used for. Generally, you only want to use static pods for running your API server, etcd, anything essential like that. You can use this for other things. I've seen people replicate things like daemon set functionality using static pods where they drop an entire workload to every node just by copying a file into a certain directory, spoilers for what's coming up ahead. I had a really interesting conversation at KCD the other day where someone was talking about sharding some of the control plane workloads. And if you're running control plane at scale, this can actually be more efficient than running daemon sets. So if you have a huge amount of compute, think your cloud running something like the Azure serverless thing that's actually Kubernetes but pretends it isn't, but really it is. I can't remember the name. This can actually be a version, but for most people, static pods are used to launch your control plane. So, effectively, in the kubelet config, in a vanilla kubeadm cluster, I'm sure this is going to be different for various people's clusters. Again, I use kubeadm as a base because it's kind of the most representative. We have a file that says, I would like to look in the directory etc kubernetes manifests. If you go into any kubeadm-based deployment and go into this directory, you will see a few files, especially on the control plane. You can technically set this to a web endpoint as well, so you can actually have every node reach out to an HTTP endpoint to get a static definition. I've never seen anyone do this in production. If anyone does this in production, I'd be really interested to know why, because I can't think of many legitimate use cases, and the attack surface here becomes a bit scary. The spoilers for what's coming up ahead. Anyone who can write to this directory can create a pod running as root on your node and get full admin over that node. If you're calling out to an endpoint and an attacker can get access to that endpoint, they can do the same. They just get remote code execution as a service into your cluster. Interestingly, this is not mentioned in the current CIS benchmarks. So anyone who thinks CIS benchmarks are the be all and end all of security, please come and speak to me because I have opinions, many of them. But specifically, this is actually not in the CIS benchmark. And I don't think it will be for about 3 weeks when we're trying to get it into the next release, because this is something that we think should be there. Fun conversations ensuing. CIS benchmarks, for anyone who's not familiar, are a kind of industry standard for here's the best efforts at defining how to secure a platform. I used to think that they were defined by a group of grand wizards in the mountains of Germany in a forest under a full moon. Turns out anyone can rock up and just be like, I think this thing should be added, please. And you'll either get told yes or no, or go away. We spoke about this 4 years ago, read your history. That was an aside. So, in the static manifest directory, in a vanilla kubeadm cluster, you will have 4 pods. You've got the etcd, kube API server, controller manager, and kube scheduler. Basically, the important components for a cluster to be able to run and bootstrap itself. So now, the kubelet is reaching out to the void and not getting anything back. But it's also reaching out to the static pods directory and saying, how about you? Have you got anything for me to do? Reads the files from the static pods directory, goes, okay, I'll run those pods, this is fine. Up come some pods. So now we have the kubelet talking to the static pods, launching those containers, and then being able to talk to the API server to let the rest of your cluster come up and online. This is us. We've bootstrapped a cluster, and now we've got some things running. The reason I started looking into this was I was writing some CTF scenarios for our CTF platform for KubeCon. And I had a scenario where, spoiler alert, there was something involving static manifest. I did some things, and the pods didn't appear. And I was really confused. So obviously, this sent me down a bit of a rabbit hole. We will discuss the details now. Normally, we can just say kubectl get pods. The pods are for the control plane in the kube system namespace. You can see here we have got etcd, kube API server, kube controller manager, and the scheduler. These are all suffixed with the name kind control plane. That's the name of the node, and it's the only node in a default kind cluster. If you had multiple nodes running, you'll quite often see these with like API server, kube master role 1, kube master role 2. These are just the host name of the node that these pods have been scheduled on. So this means that we can talk to the API server and get details about the pods that are running, even though those were defined in a static file on a single node. The way the lookup works through kubectl is we talk to the API server. The API server goes to etcd, which is the data store of a cluster, and says, what workloads have you got running on this node? Just give me the details back, please. It's basically a selector saying, what pods have you got with this node? So these have been registered somehow with the API server, which means that something has happened to create the pods. But we also know from a security point of view that we can restrict what pods are able to do. So it used to be in Kubernetes that if you could create a pod, instantly got cluster admin. There was no way of stopping this. there is a manifest called the most pointless Kubernetes command ever, which is a reference to Ian Meal's the most pointless Docker command ever, which is a way of creating a container which turns off all of the isolation between a container and the host. So containers are basically just Linux processes that have been tricked into thinking they're their own standalone object. Realistically, you can turn off all of the security. You can have the host file system be accessed. You can have the host process namespaces be accessed. You can create a container that has full access on a cluster, on a node, a cluster, whatever. There's a lot going on recently and over the last probably 5 years to make restricting this functionality a lot better. So in Kubernetes, the only native functionality used to be, can you create a pod, yes or no? Now we have built-in functionality like pod security admission, which allows you to say someone's allowed to create a pod, but only using certain fields. So in pod security standard baseline, you can create a pod that will run, but you're not allowed to use any host resources because that's a breakout from a pod to a node. There are also a bunch of other restrictions. So a few years ago, there was a great talk at KubeCon called Walls Within Walls, What's About When Your Attacker Knows Parkour, by Greg Castle and someone else whose name eludes me. Apologies to the second speaker, from Google.
Why?
I don't think it was, but I will check. I have it in the references at the end. Brilliant talk. If you want to go and see how broken things used to be, I would absolutely recommend this talk. Because it used to be that if you could create a static pod on a node, so if you've compromised a single node as an attacker, you create a pod and you just say, okay, now that I've created this pod, I would like to mount in all of the secrets from the kube system namespace into this pod that's been created. Once you've done that, you've got all the service account tokens in your cluster. You can get cluster admin by compromising a single node. Thankfully, that's not the case anymore. That's now enforced through the node authorization admission control, which basically says, if you're a pod being created on a node, you're only allowed to use secrets that you've been told to access. The kubelet is only allowed to add secrets it knows about. But also, if it's a static pod, you're not allowed to mount any secrets. So this is all fairly good. This is locking down some levels of security. What's interesting, though, is we've spoken about restricting what the kubelet's allowed to do. We've spoken about what users are allowed to do. There's a lot of different authorization bits at play here. And when there's lots of components trying to make a decision, we quite often find that they don't interact quite as nicely as we'd like. Fun fact about Kubernetes authorization, authorization modes either return yes, maybe, or no. Almost no authorizers actually return no. Kubernetes RBAC only returns a maybe. So you can actually enable clusters that don't allow something through RBAC but do allow through node authorization, that will go through. There's various edge cases, and this just sounds really weird, and I don't like it because multiple APIs and trench codes pretending to do the same thing rarely do. So I started prodding this to find out what was going on. Who here, I kind of want to do a mandatory participation thing because we did this internally at ControlPlane. Who thinks static pods are subject to admission control through pod security admission? And who thinks they completely bypass it? Cool. Those of you who've answered, that's what I thought as well. I assumed that a static pod would completely bypass pod security admission and would allow you to create a privileged pod where you couldn't through kubectl. It turns out that this is not the case, but also it kind of is. And I realize that that's misleading, and that's because I need you to keep listening, because I can tell that some people are probably getting bored by now. So I have here two manifests. I have a standard pod, which is just saying, create a standard pod. I'm doing this in a namespace called baseline, which I've labeled with pod security standard baseline. So pod security admission will not allow a privileged pod in this namespace. I have a link at the end of these to the manifest I used to play with this. They're fairly basic, but if anyone wants to play about themselves, everything is available. I'm also going to try and create a privileged pod. So the only difference here being I've said security context privileged true. Privileged is basically the insecure flag. It's the do not do this, this is really insecure. System components that need permissions, probably okay. If any of you are running a cluster and the dev says, I would like to run just a normal web app, but it needs privileged, ask them what the hell they're doing and why they need that. This should never be allowed for a production workload. So I've applied both of those manifests and I've put them both into the static pods directory. But if I do kubectl get pods, I only see the standard pod running. So this looks like pod security admission has done its thing and said, okay, standard pod, fine, carry on, sir. Privileged pod, go away. but I wasn't quite convinced. And the reason I wasn't quite convinced was when I was trying this out, I got a reverse shell from the container I created in testing, but the pod wasn't running. But I had a shell. That doesn't seem right. Cue a descent into madness around 11 p.m. I think my message history internally mirrors this because it was weird. There's the kubelet logs for journalctl on the kubelet saying, okay, standard pod, that's been created. There's the log for the privileged pod creation saying API server says no. So everything we've got so far still suggests the API server has said, no, you're not allowed, workload will not be created. This made me think, okay, the kubelet is doing a pre-flight check to say, am I allowed to create this workload? The API server has said, that spec's not allowed, don't create the workload. I'll refer to my previous comment, I had a shell. I had a connection back. So let's dive a little bit deeper. CRI-CTL, cry control, critical, whatever you want to say. I'm sure everyone has their own one. CRI-CTL is a way of talking directly to the container runtime, rather than using Docker PS or CTR PS for container D or CRI control. CRI-CTL is a more abstracted way of talking to any container runtime. And it shows 2 pods running. This text might be small at the back, but trust me, there's one there that says privilege, there's one there that says standard. So what we actually have is a pod that is running on the node that has not been able to be registered with the API server. This is kind of expected because it means that the kubelet isn't doing a pre-flight check to make sure the workloads are allowed. But also it means that a security control in place in the cluster is not working as we expect it to. If you take the definition of pod security admission prevents the creation of a privileged pod, we've proved it doesn't. Now, we can all ignore the fact that you could just schedule a workload into kube system here. Let's not talk about that because that will break things, but let's keep the model fairly simple. So I wanted to just confirm this a couple of times. And what I found was that CRI-CTL pods also says the same thing. So PS just says, give me a list of all the containers. Pods says, give me the pod ID. We've basically confirmed at this point that the pod is definitely running. Even more interestingly, kubelet-CTL is a tool that came out of CyberArk a few years ago. The kubelet API is really poorly documented. It used to be that the only place you could find the endpoints available were in the kubelet's own source code. Then CyberArk came out and wrote kubelet-CTL, which is kubectl, but for talking directly to the kubelet. If you use this, you can actually talk and you can see that the pods are running. So if I can talk to TCP 10250 on the nodes, I get confirmation, as long as I can authenticate, I was cluster admin here, I cheated, that everything is actually running as expected. I have a workload that I can run that doesn't show up in kubectl. The reason I think this is particularly interesting is Andy and I have been talking a lot lately about persistence in Kubernetes clusters. Most specifically, if I'm an attacker and I break into your cluster and I get cluster admin for however short an amount of time, can you be sure you can get rid of me? So it might be that you go, oh, I'll kubectl stop all of the pods that I think you've touched. But you can't kubectl stop this pod because kubectl doesn't know this pod exists. The API server does not know. So now, if you're trying to defend your clusters, you need to be looking at the container runtime directly, as well as looking at your kubectl logs. If you've got any observability on your containers, this is a really important place to be checking, just to find out to be sure you actually know what's running everywhere. Fun fact, you can also actually create pods in namespaces that don't exist doing the exact same thing. You do still get errors back from the API server. Interestingly, some container network interfaces actually get really sad if you do this. Again, the easy way of bypassing this is just to use net host so that the container network interface doesn't get involved. You're just using the host's network. But yeah, this is really weird functionality. So this is me trying to create a pod in a namespace called fakeNS, which didn't exist. And funnily enough, the API server says, whoa, that doesn't exist, go away. But again, if I do a CRI-CTL PS, my pod in the fake namespace is running on the control plane. So there's a few ways of looking at this. There is no legitimate use for this functionality. There is no world where a normal administrator doing legitimate administrative things should be creating a pod in namespace that doesn't exist and doesn't show up in tooling. The best use I can come up for this is I'm a nasty hacker man and I like hiding from people who are trying to find me. And this is a really nice way of doing something along those lines. I know full well that there are many other ways we could do this. I could create a pod or a container in a different container D namespace. Fun fact I learned the other day, container D actually uses the k-test.io container D namespace. The kubelet uses that in container D. That's hard coded. So if you ever want to change that in your cluster, you actually need to recompile the kubelets, which is not difficult to do, but it's a bit of a pain. I was kind of hoping for a config file. This is mostly useful to me for attacker persistence. It's not the only way we can get persistence. There's so many ways, especially because these are just Linux nodes. There's also an interesting discussion that arguably this isn't a problem because anyone who can do this already has admin on the nodes. In most flavors of Kubernetes, the static manifest directory is restricted to the root user only. I have once seen a customer who changed that directory for some reason and had other people be able to write into that directory than the root user, which again is just a privilege escalation on a node. And this is the part of the talk where I really wish I had a useful take-home message and how you can use this to somehow improve the performance of your clusters or boost your security or something. I really don't. This is just weird, and I like talking about weird things. One thing I was discussing at KCD was, is it possible to create a container using container D and have the kubelet adopt that? So I create a container locally using the correct spec. Because the kubelet has no idea of what containers are or are not meant to be there in its own state, the kubelet doesn't write to a local database file and say, these are the pods I expect. It just holds everything in memory. I wanted to know if you can trick the kubelet into adopting a workload of yours, not by using the static directory. Again, the easy way to do it is just use a static file, but that's boring and I don't know what the kubelet does when you poke it weird, so I wanted to find out. The consensus seems to be that what the kubelet will actually do is go, that's a pod, but it's not what I'm expecting, and it will kill the container, which is a fairly sensible argument I'm happy to go with, but I'm definitely going to go and try it, because this is just weird. So, as I say, I can't really think of any legitimate uses for this. If you are monitoring clusters for security reasons, it's definitely something to watch out for, because, as I say, this is weird, and security tooling doesn't tend to notice weird things as much as it should. It's just odd. I thought it was fun. I hope you all did as well. Thank you for listening. If you've got any questions, contact details are there. Thank you again. And
Right, thank you very much. Again, there is an opportunity to ask a horribly spiky mace of a question if you have one.
I got a question.
Okay.
Very good.
But because, for example, this happens in any version of Kubernetes?
yes. As long as the
even the higher one.
So if you're running managed Kubernetes, the chances are the nodes, so if you're running EKS, the chances are the kubelet is still configured to check the static directories on your nodes, but you don't have access to the control plane. I have not validated this against any of the managed clouds. I tried in EKS, I fell asleep while the cluster was still spinning up. I'll do it at some point. I didn't really, I just wanted to dig at how slow EKS CTL is. I haven't actually tried this on any of the managed clusters, but almost every cluster I've checked, including Talos, I thought if anything was going to not use this, it would be Talos, and it does. I'm sure there will be a weird and wonderful flavor that doesn't use static directories at all. Rancher might not, because Rancher doesn't run the control plane containerized, but I haven't checked. I suspect it's applicable to 99% of Kubernetes clusters.
This is a kind of bypass, like a Windows bypass.
Well, it is and it isn't. It's all normal. It's working as intended. So all of these components are doing exactly what they're meant to do. It's just you can make them do weird things. So I have a history of raising issues with Kubernetes. I'm going to mention this in like 10 seconds. You can actually label a namespace from inside itself, which breaks pod security admission if you've got the right RBAC permissions. Happy to talk about that later. I raised this with SIGAuth, and their response was, that's really weird. I can't imagine why that would work, but now that it does, that's working as intended. So that seems to just be the response. It's like, yeah, we accept that that's weird, just deal with it, which is great for someone who breaks into clusters for a living.
For this, you can use any container image?
Yes, as long as the container runtime can pull or start that image, yes.
So you can use a Hue image with a Hue consuming memory?
Yep.
Okay, so you can overflow
I
The
do
Kubernetes.
I do not know if resource limits apply. I suspect they don't. But interestingly, static pods have a lower priority in the scheduler than pods scheduled through the API server. So if you create a really noisy static pod and a bunch of normal workloads are also trying to be scheduled on that node, the API server will instruct the kubelet to evict static pods before it instructs them to evict API server pods. But yes, you could DOS this somehow, absolutely. You can also use this to get access to private images that you're not allowed to pull because they're already on the nodes. So you could just say, start a pod using an image that you've already got, and I'll use that one instead of talking to the registry.
World of fun, and it's Mr. Tim Aldler.
Tim Aldler,
not
thank you.
Sigler. Totally confusing.
There's too many Tims. There is a Sig Tim, I think. There should be if there isn't already.
All right, once more, thank you very much. And we have one moment before set up. If you do need to get another drink, please return to your seats within the next couple of minutes, and we will kick off with the grand finale in just 2 minutes.
I send the.
How do you choose it? Just security engineering.
I don't know.
Can you just open
all of
how does this
that?
work now for his work?
Oh yeah, we need to get your slides onto.
I send it to you.
My email? Oh, Jesus. See, I'm such a big fan of the website on my home screen. Just saying.
Use Google
See, I'm
Slides.
such a big fan of
No,
the website on my home
PowerPoint.
screen. It's on my stage. It's like, it's my comfort website. I know, right?
I'm terrified for you. Is everything okay?
You sent it to this email. Hello, where are you?
Starting to get sent.
Do you want to sing a song?
I'm just saying, right.
No. Oh, you went,
Sign out the box. No,
no, that's the last one I have.
it's my last answer. I don't know why the. Because, I don't know why in the Outlook web won't let me attach.
Do you have the Wi-Fi?
No, I got my.
Oh, okay. Oh, I got it now. Got it. Ian, sorry. So these are Antonio's slides.
Yep. Do you want them ready to present?
Please, and I don't.
Make your magic. So with that you can abuse Kubernetes.
Oh, you can break so much stuff, but it's working. It's what's meant to happen.
Nice. It's good, man. I never heard about
And
that.
will they just are they automatically linked to the?
I'll double check. Do you want speaker notes? Yeah.
No.
No, you okay with that? Brilliant. Full screen, you prick. So Command F was optional. Oh right, I see.
Go back.
Because it's a PowerPoint, it's going to get a bit confused, but we can probably. There we go. And I'll just triple check. Sorry, it's that
Yeah.
one. Yep, we're good.
Oh, wow, great.
You all right?
Thank you.
All right. Do you want Clicker? Do you want this? Oh, hang on, let me just let me just hide this. Sorry, this isn't even my laptop. Do you want to try that? Yeah, do you want to give the clicker a go and see? Perfect.
No, yes.
Everything's streaming. This is ready.
Yeah. We're ready for it.
Right, ladies, gentlemen, and the piece de resistance, the imported friend from another DevSecCon chapter in Spain, who has come in specially to grace us with his security presence. Antonio, it's very nice to have you here. Worked at JPMC and also involved in B-sides and community events across Spain. And we're looking forward to hearing about how to break into and then fix the clusters that we know, love, and hopefully keep us gainfully employed. A final thunderous and rapturous round of applause. Over to you, sir.
Nice presentation. Thanks so much.
Well, this is a intro medium, no talk, because we don't have too much time. It's about how to attack and defend Kubernetes. The other colleagues speak a lot about how some vulnerabilities and some findings. No, this is mine. That has some light. Take a picture. How Andy said, well, yes, I am DevSecOps. I started as programmer in my life, programming in PHP, later in C#, and I evolved like a Pokemon, evolved. So I like a lot security since the beginning, since I programming. And well, when I moved to Spain, I became DevSecOps. Well, becoming DevOps because 8 years ago, the DevSecOps concept no exists itself. It's security, it's DevOps, but not DevSecOps itself. Well, yes, I am working as consultant in JPMC actually, so that's the reason I'm here in London. I got, I don't know, 15 years in IT world. So the first thing is introduction to containers. Many of you know how is a container. Container is a solution. No, we can use Docker or interface, Podman, all of that to micro virtualize applications or microservices, whatever we want. My question to Ian is because there is some huge image, but that huge image, 6 gigabits or something like that, that is more than a microservice. Okay. Well, we can see here the difference between how to virtualize in virtual machines and how to virtualize in containers. How it's working, the infrastructure, how it's working in the house operating system layer, and other things. Okay. We know that the benefits of container is work with microservices, small pieces of a big software or big engineering software. We are working with minimal OS before, for people that doesn't know. When we start in this world, I remember that there is a huge image with Ubuntu, or now it says the minimum one is Alpine. Alpine now, the Alpine size is kilobytes. And even Ubuntu minimize the image too. It's very flexible and multi-platform. Now with containers, we can run in Mac, Windows, and Linux. And well, it's nice. We can see the portability is very cost efficiency and even one of the most benefits for me is integrating the functionalities inside the CI/CD to deploy and work with the different images. So now we're going to talk about Kubernetes. Everyone here knows what is Kubernetes? Yes? Okay, nice. We know that Kubernetes is a container platform to manage the containers, to deploy it. It's a platform itself. It's a cloud native. Cloud native means that running cloud, but we can use in managed servers. Actually, it's cloud agnostic. Okay, we can run any Kubernetes platform, flavor, or whatever we want in any cloud or in any place. And even it's flexible, like the container itself. It's a DevOps philosophy. Well, Kubernetes vulnerabilities. Okay, the first things I want to talk here is the OWASP top 10. You know what is OWASP top 10? Yes? We know OWASP top 10 start with the web application security frameworks and evaluate the most cybersecurity issues that we find in web application, and later they use the same top 10 for different stuff. We have top 10 for containers, we have top 10 for Kubernetes and other things, even for IoT and mobile applications. So the third things here, these top 10s I found is 2022. It's not updated. The first vulnerability we can find and is one thing that you're talking about is insecure workload configurations. So the other thing is supply chain vulnerability. Here, anybody knows what is supply chain? Yes? Okay. Vulnerability, for who knows, who don't know, is supply chain vulnerability is when we find, for example, libraries from libraries, third parties, and all of these kind of like Log4j and other vulnerabilities inside the different contributors in the chain of the software. Other thing is that he told Ian is about airbag permissions. Okay, overly permissive airbag configuration is when a role overlay the permission, the secure permissions inside the cluster. When we work in a Kubernetes cluster, we have airbag permission to control the security of execution of different pods in the different namespaces with policy. We can control it with policies, with network policies, and a lot of things. The other vulnerabilities we can find here in this top 10 is lack of centralized policy enforcement is when we deploy by default Kubernetes, is a lack of policies. We need to enforce this cluster with different policies that we need to segregate the security for the different containers. The other thing, and it's important, and Ian mentioned, is the inadequate logging and monitoring clusters. When we have a cluster, we think, okay, it's enough just watching the workloads deployed and just watching the consuming of the CPU or memory or even the storage. But no, it's more than that. Is as he say, we need a real monitorization about everything that is deployed in terms of Kubernetes resources. Everything inside Kubernetes is a resource. Okay, so we have some kind of software that let us make some inventory about this access. Okay. Other vulnerability here we can find is broken authentication mechanisms. Is something like you speak, no? Is about the security between pods and security in between even namespaces. Secrets management failures. A lot of people think that saving secrets inside Kubernetes in base 64 is the best way to store secrets. Or even using some secrets rotation and oh, we are fine because we are rotating secrets. No, you still storage in base 64. Misconfigured cluster components is about resources, it's about the nodes. We can explode a node and we can attack since that. Okay, and one of the important thing is outdated and vulnerable Kubernetes. The Kubernetes release is each 6 months. So they have extended support, and after that, any version is outdated. So the extended support is like 4 versions, no, something like that. 3 versions is the extended support. Okay, so I will talk other attacks. For example, we mentioned here API server exploitation. We can reach the, how Ian mentioned, the Kubernetes have some API to control different stuff inside Kubernetes. Okay, we can access to this API when this exposes. So some of this via misconfiguration or via weak authentication, we can access to them. We can even create, if we can access to the schedule, we can create new pods, vulnerable pods, or whatever the attacker needs to persistence or whatever they want. The other thing is, I mentioned, is misconfigured airbag. This is for me, the best one. I love it. Container escapes is when an attacker compromise a containerized application and exploit vulnerabilities inside the container and can escalate. When we don't control the security controls, the security context. If we don't control the security context in the container and in the pod, we have a good scenario to get some fun. No? I got other attacks here. For example, Kubernetes exploitation. The Kubernetes agent running in each node and has access to critical cluster management functionality. Kubernetes is the application, as Ian mentioned, that manage the different components inside the Kubernetes. So sometimes the kubelet is exposed via insecure ports or by misconfigured settings. The potential damage here, we can see, is the attacker can gain control over node components and execute malicious workloads. Okay, this is from the exposed XCD data store. Is other attack, very funny. Is when the everybody knows here what is the XCD. Okay, nice. It's a good public. very pro. Okay. The XCD, we know that is the key value store database that have the knowledge, this pod, the name, and where is deployed. So even if we delete or we attack the XCD, we can compromise the whole cluster, and we can destroy the cluster or have a bad afternoon, bad night to anyone. Unrestricted access to node ports. There is some workloads that the workloads we can deploy as load balancers, as node ports, or normal, is internal the communication. But when we deploy an access a pod as node port, we can expose this pod to the whole network. So any attacker can access to this pod. One of the best ones, CI/CD pipeline compromise. I have a talk about how compromise Jenkins. When we compromise a CI/CD pipeline, the pipeline when we want to deploy an application, the pipeline have access to the cluster, to any cluster, because retrieve the credential and all of this. So if we can compromise a pipeline, we can access to any cluster that this pipeline have access. Service account token exposure is nice. It's a good attack. You know that the services, the pods, and many of components is running via service account. It's not like when we run. Let me explain that. When we try to run or rise any components, a service account is the executor of this component. So this service account depends on the scenario. Use the token to connect. For example, if we won't connect into the cloud, so we need to a service account with a token and all of this. So can be compromised. The 9 is denial of service. DOS is the most popular attacks when we're trying in any kind of service. And the last one, I was investigating about this. It's very interesting. The last one is man-in-the-middle attacks. I didn't try it in any moment, a man-in-the-middle attack, and it's very interesting because, as I write here, if an internal communication between components like API servers, kubelet, and etcd is encrypted, the attacker may intercept or alter the traffic between them. And yes, the potential damage is intercept credentials, because when we have multi-cluster, when we have nodes in different regions or the deployment of different nodes, one node to other node is communicate via tokens with the services, and we can use a man in the middle to intercept the credential, to intercept the token, and later we can use the token to connect to the other nodes. And well, we start here the defense. For the first one, API server exploitation, one of the strategies to defense is implement a good airbag to limit access based on the least privileges. These privileges is not zero trust yet. The zero trust is the best way, but less privilege is the next step when we can implement the zero trust. Okay, using network policies to limit API access to trusted sources, and not just for APIs. The network policies works for anything, in any workload inside the Kubernetes. Enforce authentication mechanisms such as TLS encryption and OIDC. When you're talking about service mesh, we talk about encrypted all traffic with TLS encryption. Okay, so when we implement a service mesh, it's literally avoid many of these issues. For misconfigured airbag, obviously we implement the principle of less privilege for all roles, and regularly audit the airbag policies using tools like kubectl or Rackets or other things. Use namespace isolation to limit the scope of access. For example, actually, I work with a lot of these. Many of the service accounts that we use to deploy our application cannot access to other namespaces, and this made us more secure in the security aspect, in the security topic. But for example, the other day I received a task to investigate that if one service account want to use a pod in other namespace and rise up and delete the pods, and we raise the hand because it's a security concern. Because this service account is from other team, and they make some tests, and we really not like that they can delete all pods. For container escape, use pod security policies to prevent running privileged container, or the more basic stuff is security context running as non-root, and just that. It's the best way. It's the best way to avoid the container escape. As non-root. Okay. Regularly patch the container image and house OS. For example, this is funny because many of people. This is together the other one, limit container privilege by using minimal basis image and dropping unnecessary Linux capabilities. Goes together because everybody doesn't know that when we use some image, for example, if we want, if we want to use Python 3.4, Python 3.4 maybe have the maybe have SSH, So why Python needs OpenSSH? And if Python running the Python image, I'm talking about Python image, and if Python image running SSH, it's a kind of vulnerability, okay? Because if we're not patching the OpenSSH and OpenSSH have a vulnerability, the attacker can exploit this vulnerability. Okay. No, I invented. It's not a normal case. No, no have to happen. Never. The other thing, the number 4 is Kubernetes exploitation. Okay. Disable the Kubernetes anonymous access. Require TLS certificates for Kubernetes authentication and communication, okay, and limit the access to Kubernetes API by using firewalls and network policies. For example, in the most of managed Kubernetes flavors, you don't have access to the control plane, and you don't have access to this Kubernetes and other stuff. You just have access to your pods, your namespaces, and other lower resources. For expose XCD data store, we have use encryption at rest for sensitive data, especially in XCD. The same thing, airbag for XCD, and you use TLS encryption for communication. This one I told before for node ports. One way to avoid is the exposure via node port is using load balancer or using ingress controllers, okay, or implement the firewall rules. It's not something normal that an application or service needs the node port more than for testing. In the case of CI/CD pipeline compromise, store Kubernetes credentials securely using tools like Secret Manager or HashiCorp Vault. Okay, is really the best way to keep secrets. Okay, integrate security into the CI/CD pipeline with tools like Kubebench for compliance checks and kubesec for security assessment. More than that, there is a lot application for that. Even I work in a personal project. We name it OSDO, Open DevSecOps. In OSDO, we create a secure CI/CD from the beginning. We secure the code, we secure the containers, and we secure the deployment in OSDO. So for me, the best way literally is creating a secure CI/CD more than just integration tools. The service account token exposure, well, we have disable auto mounting of service account tokens for pods that don't need them. Use minimalist service account with restricted permission that I mentioned before in my case, when a service account is just for this namespace and just for this application and not do anything more than the duty is just work with an application. Okay, rotate token regularly is something crazy, but we have a secret rotation implemented, and we regularly rotate tokens, but not for all service accounts, just for one specific account. This is Snyk, and this is my question. Implement resource quotes and limits. Okay, I question to Ian if we can use with this bypass bigger images. Is because this. If we now implement a resource quotes or limits in the pods execution or for namespaces, we can make a DOS in the cluster, or we can break the budget of the company. In the past, when we start using Kubernetes, there is a lot of attacks abusing the resource quotes, because most of the companies now use these things. And for the horizontal pod scaling, auto scaling is one of the best ways to control the pods. Never forget that. And obviously enable API rate limit. But for example, enable API rate limiting. We used to do it, or we can use a service mesh for this, and we can control the rate limit via service mesh. We can control it via load balancer, or we can control it via API gateway. So in the most popular cases for big and medium companies, they have always load balancers, or they always use the cloud and have a load balancer in the cloud, have all of these kind of tools that help to avoid exploiting the rate limit. And for man in the middle, there is no other thing that using TLS encryption. Okay, and implement mutual TLS to authenticate components like API servers, kubelet, and pods, and whatever you want. We have here the best practices. Okay, using network policies, using security context, make image security to scanning containers, a good secret management, a good logging and monitoring, a good patch management. Okay, we are actually because we are a big company, we are fighting with the continuous patching, because we have to upgrade the EKS version, and this EKS version is not compatible with the application version. And this application version is not. Wow, it's a big deal working with patch management. And I'm finished. I don't know, it's boring. Sorry, it's boring. I'm trying to.
Thank you very much. Well, you know what that means. There is space for the most difficult questions that anybody can possibly think of. I know.
We have time. Yeah.
We have a moment. If people have things, you feel free. Yes, you have a question.
You pay for the OWASP top 10.
I can hear you.
The OWASP top 10, but the centralized management on the Kubernetes cluster. How would you go about that? Configuration management, like Ansible, or like a configuration driven?
It's a good question. It depends on the quality of the company. For example, we now deploy we just use the Terraform and roll out the updates for the management and the deployment of the different processes. Maybe some companies using Ansible to roll out the updates and all of that. The system.
Okay.
Anyone? You have questions? Your fail is with questions.
What about without Kubernetes? Is it more secure? Without using Kubernetes, the ecosystem will be more secure?
Yes.
Ian say no. Ian explode Kubernetes.
I reckon if we turn all the computers off and bury them somewhere, they'll be more
No, but no, the answer is just not the most no, it's not secure.
Right, very good. Well, once more, thank you so much for coming all the way here and sharing your knowledge with us. A round of applause for and thank you to everyone.
I want to make some propaganda. I running a conference in Spain, okay? It's SOX conference. If someone here is in Spain between 22nd and 23rd of November, is invited to go to SOX conference, okay?
And which city or town is it in?
Huh?
Whereabouts?
The SOX conference is about SOX. The SOX is the umbrella of the different ops disciplines, DevOps, DevSecOps, and
What city?
BSOps, AOps, MLOps.
What city?
What?
Is it Barcelona?
Where?
In Madrid, sorry. In Madrid. I run in Madrid, so you're invited. Someone is in Madrid.
Wonderful. Well, excellent. Thanks for everybody coming, everybody who has enjoyed the live stream. I hope it was all as transparent and eloquent as it was this end as well. Thank you everybody for coming. There are still some drinks. Please do feel free to drown your sorrows for tomorrow in advance. And we'll see you next time. Thank you very much.
Oh, hello. Good. Thank you. Bye-bye. Bye. Bye. Figure this out. Yeah, if you go all the way around, it's like literally on the other side of the building. Am I being dumb? Yeah, it won't let me. Am I being dumb? Ian, why won't it let me in?
What's up?
Why won't it let my mouse move over here?
Maybe it's on the other screen. It's just there.
See, don't look at me. Okay, it's my
I'm
fault.
blocking the screen for your benefit.
Right, it is.